Hey everybody, so we'll continue with chapter 1 and this deals with the Cartesian coordinate system. So we'll see different type of problems like distance and circle, and it's built on an area of algebra. So I'll go ahead and switch the screen, and I think we'll solve some problems at the end, of course, because this section has a different type of problems when it comes to the homework. So we'll do some here and do some in class. Okay, thank you. So when it comes, everybody kind of knows the Cartesian coordinate system by Descartes, French mathematician. And we have the origin, we have the x-axis and the y-axis, and the positive side for the x-axis. And so those things are not a problem. And so you have some more details there. So there isn't much really to talk about there, but you can, you can review it. But I'm sure everybody have seen these before. And if you can just refresh quickly the memory on these. So the point Pxy, if it's 2, 1, then you look for x2 and you look for y as 1, and the intersection is the location, just like in GPS. All right, and of course you can, if you need the details, you can pause the video and go through these details that are explained. And but this is an example. So 3, 2, right? You get point E, 3, 2. What some of the interesting ones you need to know, of course, the origin is 0, 0. Any point on the x-axis will have the y value as 0. Any point on the y-axis will have x as 0. So this something you need to keep in mind. And the quadrants, they go kind of counterclockwise. They don't go clockwise. They go 1, 2, 3, 4. And plus plus means positive values of x and y, or we call these ordered pairs because they are in order. It's x and y. So x is all positive here, y all positive, and of course the others. And so these are not an issue. And anytime we say positive, we also mean x less than, like for here, x is greater than 0, y is greater than 0. So that's the notation, these notations you see here. So here x is less than 0, y is less than 0 means both of them are negative in third quadrant. The distance formula, since we're dealing with the 2D problem, two-dimensional, x and y, this is one dimension, this is the other. The distance formula comes from Pythagorean theorem that usually. So this distance, which is the hypotenuse, is going to be this distance squared plus this distance squared. Usually you do the hypotenuse squared, right? But if you're interested only in D, so let's call this A and this B. So usually you would do D squared equal A squared plus B squared, right? Then of course, if you're interested in D, you do a square root of that. And so that's where the distance formula comes from. So the difference of the x's, this is x2 and this is x1. So to explain it a little more, x2 minus x1 would give us this distance. And the upper part, this is y2 and this is y1. So this is same as that. So if you, that will help you can memorize it easier. So the distance between 2 points, x1, y1, p2, x2, y2, or the right way to say, of course, point p1 has the coordinates x1 and y1. Is x2 minus x1 squared that difference of the run of the horizontal and that difference of the vertical, right? So that's the distance formula, and the common mistake is to forget to take a square root at the end, this one here. So don't forget to take that. And a few things that this may not be talking about is the exact value. So if we come up with, let's just say distance equal a square root of 2, then let's say meters. Then the distance is exactly square root of 2. But if you decide to use a calculator, you know, what is this square root of 2? So if you do on your calculator square root of 2, you're going to get a number that doesn't end really, like 1, so forth. So what are you going to take? You will have to approximate to a certain value, for example, 2 places, right? 3 places, whichever is asked. In that case, you approximate. You do some approximation there. So just keep in mind that if you're not asked for the approximation, don't use it. Give the exact value. Anytime you do in algebra, the distance a circle follows, because a circle is points, right, that have same distance from the center. All right, so that's why this thing follows it right away. And from that formula, we'll come up with now the distance is going to be r. So it's the same thing, right? So let's look here. The center is HK, so the first point and the second point. So we'll do y2 minus y1, which is y minus k, and x2 minus x1, x minus h, right? So that's where this formula is going to come up from. So, and the distance, which is that same distance, which is r. So x minus h squared plus y minus k squared, right? And the other point, call it pxy. So any point on the circle, right? And this is r. And if you square both sides, you'll get the circle. There are 2 forms for this circle equation, but this is the center radius form. All right, so you get r squared equal this way. So here is an equation of the circle with the center c, with coordinates hk, and radius r is given by this formula. Keep in mind again, so the note here, if r is 5, then the formula, you know, has 25. Then, you know, so you need to watch whether you have r squared or r. So if r equal 5, then x minus h squared plus y minus k squared equal 5 squared or 25. So if you see 25, r is 5, or if you see 5 squared, right? But so A, so let's look at B. If we have x minus h squared plus y minus k squared equal 5, right? Not squared. What does that mean? This is not r, this is r squared. So r is the square root of 5. All right, so that's what you need to watch for when it comes to this formula. And the special case for it, let's do another note. A special case for it is when the circle happens at the center. When it happens at the center, h and k are 0, 0. So if you put you know, 0 here and 0 here, what do you get? You get x squared minus plus y squared equal r squared. So you get x squared plus y squared equal r squared. And r is this radius. Right, so if you see it this way, that's what it means. All right, so let's look at some homework problems to finish up this presentation. So for example, find the distance, let's say, for example, find the distance d between 2 points 0, 3 and 6, 11. So one way you can draw this on the Cartesian coordinate system and you can measure that distance, or another way we can call this one point 1, point 2, and we can go ahead and use the formula x2 minus x1 squared plus y2 minus y1 squared, and x2 is 6 and this is 0. 11 minus 3 and that's squared, and that's 6 squared, 36. All right, and 8, which is a 64. All right, and 10, 6 and 9, which is 100. And you see, the common mistake is to say this, but really the answer is 10. So you need to review to simplify radicals, and that's why we did that review of pre-calc, where you review this part. So you want to make sure you take a square root first. So note, common mistake is d equal 100, right? So, all right, so let's look at something different. I think this thing won't be an issue. We'll leave some others to do maybe live in class. So distance can be as well a word problem. We're figuring out, for example, we have 2 ships taking off, one due north and one due east, right? And the first one sails at 50 miles per hour. It's not specified here, nautical hour, miles or something, it just says 50 miles per hour, where the east is doing this. Find that expression in terms of time, because you see with time, if this one is here and this one is here, the distance is that, and maybe with time, this is going to change. So this varies. This distance between the 2 ships varies with time. So one question is find that distance in terms of times. All right. So what is this distance as a function of time? And of course, it may look difficult. So we need to think about to set it up. First, due north, we draw, towards north. Due east, we draw towards east. Then we say, okay, if it is here, and this one, and this at the given time t, and this one is here. Let's just say that approximate. But let's be, because one is faster, so let's just say one went further than the other one. So now we're interested in this distance here. We know the distance formula is x2, x1 and stuff. So let's give these point coordinates, right? So that's one way we need to figure out. Since this point is, if we consider this is the y-axis, this point is on the y-axis, then x is 0. And this point is on the x-axis, then y is 0. For this distance here is how far the ship reached after a given t time, right? So let's look at the rate or the speed. We know it's d over t. And this 50 miles per hour is how much distance per time. So if you cross multiply, you get d equals 50 times t. So if any time for this ship, if you want to know how far it is, you're gonna multiply its speed by the time. You want for 2 hours, so it's 50 times 2, so it's 100 miles away, right? So something like that. So we'll put 50t. We'll do a similar thing here. The rate of speed is the distance over time. So r here is 30. So if you cross multiply, you get d equal 30t. And once you have these 2 points, now you can, let's say we have P1 is 0.50t, and we have P2 is 30t 0. Okay, this one x1, y1, this one x2, y2. So x, the distance formula, let's just write it. And x2 is 30t minus 50t squared, and y2 is 0 minus y1, 30t minus 0, 30t minus 0. So it's good to have the eraser to fix the mistakes. So x2 minus x1, right? And if you want to do it this way, so you don't switch them. And y2 minus y1, 0 minus 50t squared. So 30t squared plus 50t squared. All right. So that's 3 times 3, that's 900t squared, and 5 squared is 2500t squared. All right, so we do 900 plus 2500 t squared. Then we ask the question, is this simplified? No, because we know that this can be written this way as we did in the review. So we need to simplify this, and this simplifies to t. Okay. You see 2 zeros means 100, right? So let's do on the side. Let's check. Let's do 3400 is 34 times 100. So if, with the square root is this. This is a 10. Then you check whether 34 simplifies. If you want to check whether it simplifies, it's even, we divide by 2. So it's a 17. 17 does not break into anything. This does not simplify to anything. So 34 is 34. So 100 gives us a 10. And 34 is just a 34. And a t squared is just t. So the distance is 10 times t square root of 34. So this is a formula that doesn't care about a specific time, but it gives in terms of time, right? Which will allow you to find the distance apart between these two ships at any given time. All right, so I think the next question is if we call this part B, then maybe we go and call this part A. So now find the distance after 3 hours. So it's just going to be 10 times 3 times square root of 34. And so that's 30 square root of 34. And the instruction says round your answer to 2 decimal places, which means we're going to use a calculator. One 74.93 miles. All right, so this is the exact, and this is the approximate, right? But it satisfies whatever request is given. And I think if there are any questions else, we'll solve them when we meet. Thank you.